Hey, so what's up, seniors? Hope you're doing well. Before I start with today's lesson, let me tell you that it was real nice speaking to some of you this morning. I know that this has been kind of like a weird situation, but I hope you guys are doing well. I hope your families are safe, and so are you. And let's get started with this your second pre-cal class. Now, real quick, I have been receiving your physics assignment and your math work, so keep sending those in. Like I said this morning, physics, you're going to be working on the physics assignment that I gave you for the rest of the week. And then your math, the physics assignment is due Saturday at the latest, and your math assignment is due Friday at the latest. Both of them are, for example, the math assignment Friday at midnight, the physics assignment Saturday at midnight. But if you have any questions, you can keep texting me and asking me, and I will help you out as much as I can. So let's get started with today's lesson. It's pre-cal. The topic is transformations of functions. Notice that I'm saying transformations of functions, not quadratic, not linear, not square root, or anything like that. And what we're going to be doing, or what I'm going to be doing, is I'm going to be explaining 4 quick examples. Example number 1, ladies and gentlemen, or the first thing we're going to talk about is actually the vertical shift, which is when a graph moves upward or downward, and the formula for that is f of x, where y equals f of x plus c, where the plus means that the graph moves upward, and y equals f of x minus c, where the c moves downward. And I have a quick example here, so let me explain that to you real quick. Notice that in this formula, the function is not inside of a parentheses. Actually, it's not inside of a parentheses here, and okay, let me fix this real quick. X squared minus 2, okay? And this is not inside of a parentheses either. So vertical shift is moving upward or moving downward, and you're gonna kind of see me periodically leave the class or leave the camera, the classroom, leave the camera every once in a while because my book is over there and I don't have anywhere to put it, so I have to kind of move back and forth. But it's okay, you don't have to miss me too long. It's only gonna be a couple of seconds. So the first thing I want to talk to you guys or mention to you guys is that we have a quadratic function, a parent function. Now the parent function of a quadratic graph or a quadratic function looks like this, where the graph always goes through the origin. Now in the case of this vertical shift, that means that now the graph is not going to be passing through the origin, it's either going to be passing above the origin or below the origin. So the first one says f of x squared plus 3. And what that means is that I'm going to take this original parent function and actually move it 3 units up. That's why it's plus 3. So if I were going to graph that, it would be 1, 2, 3. And this is where more or less where it would go. And there you go, guys. Okay? That's it. Now this is your g of x equals x squared plus 3. Nothing out of the ordinary. In fact, I think it's quite easy. And that's it. That's all you're going to do for that example. And here you have f of x equals x squared minus 2. In this case, it's exactly the same thing. But obviously, if plus 3 means I go up, then minus 2 means, and you guessed it, I know you're paying attention, you're not falling asleep like you do in class. Minus 2 actually means 2 units downward. So this is my parent function, but now I'm moving 2 units downward. So from my origin, I go 2 spaces downward, and here it is, and there's my graph. And that would be f of x equals x squared minus 2. Now, real quick, guys, these examples that I'm discussing, you can follow along in your book from page 198 through page 201, and this is basically example 1A and 1B. So I'm going to let you look at it real quick, and then I'm going to come back in just a minute so we can do the second example, all right? So I know you're missing me, but don't worry, I'll be back soon enough. And I will give you about 5 more seconds just so you guys can take a look at it before I come back. 5, 4, 3, 2, 1, and here I am. So let's erase this real quick. Now this next example is actually on page 199. And now we're going to be talking about a horizontal shift. So obviously, if I look at horizontal shift, if I look at the formula real quick, the formula is different because in a horizontal shift, if you notice, f of x equals x plus c or x minus c. Now, it's in a parentheses. Whenever you have a function that's inside of a parentheses, that parentheses indicates that it's going to be a horizontal movement. And you're going to see it with quadratics. You're also going to see it in a couple of minutes with the square root and so on and so forth. But if it's in a parentheses, it means horizontal. Now, the next thing you need to understand is that if I have something, and this is example 2a, if I have f of x equals, or not f of x, I'm sorry, f of x plus 4 squared, or f of x equals x minus 2 squared, okay? Now, they both indicate, and let me fix this real quick, they both indicate a horizontal translation. It's just that this one indicates a translation to the left, and this one indicates a translation to the right. So, if you look at the formula, f of x, or f of x plus c, it says the graph moves to the left. Whenever there's a plus sign, the graph actually moves to the left. And the reason is because this is the same thing as saying x minus negative 4 squared. And you all know that x minus negative 4 squared is x plus 4. So, remembering our parent function, it actually goes through the origin. Now, the graph f of x equals x plus 4 squared actually indicates a horizontal translation to the left, just because of what I was explaining here. So, if 0, 0 is my origin, but there's a horizontal translation to the left, that means I'm going to move, in this case, you guessed it, you know you're paying attention, just like you do in class, it's actually 4 units to the left. So that means I'm going to count 4 spaces to the left, 1, 2, 3, and 4. And there it is. This is your graph of f of x equals x plus 4, 4 units to the left. Now we're actually going to see what happens with f of x equals x minus 2. So, if x plus 4 means I move my graph 4 units to the left, then x minus 2 must mean, and again you guessed it, oh my goodness, I can't believe it, you're right. It actually means that x minus 2 moves 2 units to the right. So here we go, we draw our new function, and now the graph actually passes in x in positive 2, and this is what f of x equals x minus 2 squared looks like. So there you go. I'm going to step out real quick so that I can actually let you see this without me interrupting or barging in, and then we can do the third example, and that's it. We're almost done. This is very simple, very easy. I actually kind of like teaching the class this way. There's not that much interruptions. I'll be back. Alright guys, and I'm back. I know you missed me, even though you pretend you didn't, you know you didn't. Now let's look at the third example. The third example is actually on page 200. Now we've talked about vertical shift, we've talked about horizontal shift, we've talked about quadratic equations, but the reality is, guys, that you can actually combine vertical and horizontal shift, which is what we're going to do in example number 3. But we're not going to use quadratics, we're actually going to use a square root. So we have f of x equals the square root of x minus 3 plus 4. Now I know that there's a square root function there, and believe it or not, even the 3 that's inside of the radical sign, we're going to kind of assume that it's also a parenthesis. So even if it's inside the radical sign, we're going to use the same rules we use for horizontal shift. So as we established, the first thing is that remember that there's a parent function, and if you don't remember, the parent function of a square root looks like that, looks like this, okay? But what we're going to do is actually graph the translation. So right here, we're going to graph the translation, and it's going to be slightly different. Let me do this. Let me make sure that this real quick. We're actually going to graph the translation. Now, x minus 3, just like in the formula that I explained, x minus 3 actually means that I'm going to move the function, in this case, 3 spaces to the right, because like I was saying, if it's x minus 3, that means it moves 3 spaces to the right. If it would have been x plus 3, then it would have moved 3 spaces to the left. But we count 3 spaces, 1, 2, 3. But not only is there a vertical translation, but there's also a horizontal one of +4. And if we look for the result for the vertical shift formula, if it says plus C and there's no parentheses, or it's not inside of a radical sign, means that this graph is also going to move 4 spaces up. So, real quick to recap, just in case I'm talking too fast. The x minus 3, which is inside of the radical sign, we're going to use the formula for the horizontal shift, which means that we're now going to move 3 spaces to the right. However, this graph is not only indicating that there is a horizontal shift, but also a vertical one, in which case we're going to move 4 spaces up. So we're actually going to count from the origin 1, 2, 3, 4 spaces up. And this is where I'm going to have my graph. So this would be the formula, the graph for the function f of x equals the square root of x minus 3 plus 4. Check it out, guys. It's really simple. It's really easy. Nothing out of the ordinary. And we're actually going on to our last example. I know. Can you believe we discussed almost 3 pages in this short amount of time? So let me give you a minute to look at that. I'm going to step out and look at the example real quick, and then we're going to do that, and I'm going to give you the instructions for your next assignment. So give me a couple of seconds. All right, and I'm back. I know you missed me. So let's do example number 4. Example number 4, guys, is actually on page 201 of your textbook. So we're going to do example number 4, 4A and 4B. And before that, we're actually going to talk about our reflection now. And of x equals. Now, the reflection, which is here, and again, you can look at these formulas in your book on page 198, 199, 200, and 201. We're actually going to talk about a reflection. Now, the formulas for reflection say that if y equals negative f of x, which means that the negative sign is before the function, then what that indicates is a reflection across the x-axis. And if we have y equals f of negative x, meaning that the negative sign is inside of a parentheses or a radical sign like we're going to see in the next example, then that means it's a reflection in y. So let's start real quick with the first one. First one is f of x is negative x squared. Now, always my recommendation is to draw the parent function, and we know that the parent function of the quadratic graph actually passes through the origin. Okay? It's right here. But we have a reflection, and it's a reflection across the x-axis. Now, remember that this is the x-axis and this is the y-axis. A reflection across the x-axis is to literally take the graph and flip it over upside down. So this smile, we're going to turn upside down into a frown. That's what it basically means. I know it sounds cheesy. I know it sounds corny, but since you're not here to tell me how cheesy and corny it sounds, I'm going to say the joke anyway. So what we're going to do, just to kind of recap and me not lose focus, is we're going to take this and we're actually going to flip it upside down. So the reflection across the x-axis is basically this, okay? And this is your graph of f of x, equals negative x squared. And there you go. That's it. Now we're going to do the same thing for the square root function. Now, we know, or I explained, that the square root function is actually, goes through the vertex, and this is it. Now, I also explained once again, this is the parent function for a square root. I also explained that in a square root function, every term inside of the radical, we're going to assume that it is within the confines of a parentheses, at least in order to explain these formulas. So, we're going to assume that this is f of negative x, and what this means is a reflection across the y-axis. Of course, this is the y-axis, and the reflection across the y-axis is kind of like to take this graph and literally just draw the same graph facing the other side. Reflections across the x-axis are not that common, except for maybe quadratics and some other functions. A more common reflection is the one across the y-axis. So, if we're going to do a reflection across the y-axis, we're going to do this, and this would be our original formula, f of x equals the square root of x, and this one would be g of x equals the negative square root of x. So there you go. There's your reflection. This is your parent function, and this is your reflection across the y-axis for that. And that's example number 4. And believe it or not, we're halfway done through this first section. So what are you going to do next? Well, like I said, this is not a free ride. So here, guys, is the work that you're going to be doing. You're actually going to go to page 207 of your textbooks, and you're going to answer problem 29, 31, 33, 35, 37, and 39. Okay, page 207, 29, 31, 33, 35, 37, and 39. We're going to do it the same way we've been doing it so far, which is you've taken a picture of the exercises. You can use the app Camera Scanner, or you can use your camera from your phone if it's good quality, or if you just want to flex that you've got an iPhone or a good phone or whatever. I mean, that's up to you. But you can email them to me when you're done. You can email them on Friday, or you can email them as soon as you're done. Remember that on Friday, God willing, I have another video that I'm going to upload for you guys, which would be the end of the section, or at least 1 or 2 more examples of this section. This is section 2.6 of your math books, page 198 through 201. And, well, I'm not going to say what you want me to say because you've heard it already, so, I'm not going to say it. But in all seriousness, stay safe, guys. If you have any questions, email me or text me. Stay safe, and I will see you soon. So this is your favorite teacher saying goodbye. Bye.